You should remember that benzene will react with bromine when there is UV light, or a specific mechanism, and really that involves free radical addition. We're going to consider what happens when bromine reacts with benzene without UV light. Now you remember that benzene looks like this, and that circle in the middle represents a region of high electron concentration. So if bromine is going to react with benzene, we need bromine to have a positive charge to want to react with those electrons. We want it to be an electrophile. So we got bromine, which looks like this, and we might have a small delta positive and a small delta negative, but that's unlikely to be permanent because the molecule is symmetrical. So what we want to do is try and attract the electrons to one end, resulting with the other end being delta positive. We do that using iron bromide. Iron bromide, with the bromine being electronegative, it results in the iron being delta positive, the bromines being electronegative, which pulls the electrons in that bond this way. We can show that slightly differently. And that now means that this bromine is delta positive enough, permanently delta positive enough, to be able to attack that electron ring. So what we get is a benzene molecule. The delta positive bromine attracts the electrons in the ring, and we get this happening, resulting in that. The idea being a bond comes out from the ring and bonds this carbon to the bromine here, and we get the FeBr4 minus species here coming from this. Really ought to show that happening as well. The next stage involves the loss of that electron pair back to the ring, and so what's happened is the hydrogen has been lost and it grabs onto one of the Br minuses, the H plus grabs onto one of the Br minuses to form your HBr. That regenerates, this losing a Br minus forms a FeBr3 again, and that leaves your bromine added onto your benzene ring. So we've made bromobenzene. We're going to have a look in a slightly different perspective for the same reaction and see if we can work out in a little bit more detail what's going on here. So although this way of viewing benzene is actually incorrect, it helps us to understand a little bit more detail what's going on. So what we can show is this electron pair doing this, and that produces this species here with a positive charge here, but of course that electron pair can jump here, resulting in this molecule here, this intermediate with a positive charge at the bottom, and similarly you can get that molecule there, that substance there, by that electron pair doing that. Now the idea is, of course, that none of these actually exist. They're actually alternating between those three different substances, which is why we're able to approximate all of this and write it like this. The last stage, of course, is this electron pair here rejoining the ring, making that ring complete, which is what we've got here.